wabarakatuh. Selamat pagi, salam sejahtera bagi kita semua. Apa kabar untuk para peserta? Semoga baik dan tetap semangat dalam menjalankan ibadah puasa hari ini. Selamat datang kepada para peserta di acara seminar online NEXT BDC Noteworthy Expert Talk 2022. Acara ini dapat disaksikan secara daring melalui virtual cloud meeting Zoom dan disiarkan secara langsung melalui channel YouTube Medicine UI. Baiklah, Bapak Ibu hadirin, perkenalkan, saya Indah Ramasari. Pada kesempatan yang luar biasa ini, saya akan memandu acara di pagi ini. Next BDC 2022 merupakan sebuah kegiatan webinar yang diadakan oleh Big Data Center IMERI-IDEALAB. Dalam kegiatan webinar ini bersifat diskusi dengan materi yang akan disampaikan oleh narasumber. Penyelenggaraan yang pertama ini, Big Data Center IMERI-IDEALAB bekerjasama dengan AWS atau Amazon Web Services dengan mengangkat tema Implementation of Artificial Intelligence for Big Data in Healthcare. Kami ucapkan selamat pagi dan selamat bergabung. Yang terhormat Dekan Fakultas Kedokteran Universitas Indonesia, Profesor Dr. Arif Faryal Syam, SPPD KGAH MMB. Yang terhormat Direktur IMERI FKUI, Profesor Dr. Badrul Hegar PSD, SPAK. Dan yang terhormat Ketua Big Data Center IMERI-IDEALAB, Bapak Prasandhya Astagiri Yusuf, SSI MTPSD. Yang terhormat Head of Artificial Intelligence and Digital Health System Grup IMERI, Dr. Erik Daniel Tenda, SPPD DIC PSD Finasim. Yang terhormat para narasumber, as speaker today, Mr. Lian Jackson as Healthcare and Life Science Teach Lead from Amazon Web Services at Asia Pacific and Japan. Dr. Julian Sham as Healthcare Lead from Amazon Web Services at Asia Pacific and Japan. Juga Bapak Ibu hadirin yang sudah hadir pada kesempatan pagi hari ini. Alhamdulillah, puji syukur kita panjatkan kepada Tuhan Yang Maha Esa, karena berkat rahmat-Nya kita masih bisa berkumpul pada acara webinar hari ini. Meskipun harus dilaksanakan secara daring, semoga kita senantiasa diberikan kesehatan dan keselamatan. Amin. Baiklah, sebelum kita memulai, perkenankan saya untuk membacakan susunan acara hari ini. Yang pertama, acara akan dimulai dengan sambutan-sambutan dan pembukaan acara secara resmi. Kemudian, dilanjutkan dengan penyampaian materi oleh narasumber yang hebat dari Big Data Center IMERI-IDEALAB, Bapak Prasandhya Astagiri Yusuf, SSI MTPSD, dan dari Amazon Web Services oleh Mr. Lian Jackson dan Dr. Julian Sham, yang dilanjutkan dengan sesi diskusi dan tanya-jawab yang akan dipandu oleh moderator. Yang terakhir adalah penutup. Baik, Bapak Ibu hadirin, acara selanjutnya adalah sambutan yang akan disampaikan oleh Ketua Big Data Center IMERI-IDEALAB, yang kami hormati Bapak Prasandhya Astagiri Yusuf, SSI MTPSD. Kami silakan untuk memberikan sambutan.
Baik, terima kasih Mbak Indah. Suara saya terdengar ya?
Terdengar, Pak.
Ya. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi, salam sejahtera dan salam sehat untuk kita semua. Yang terhormat Pak Dekan, Prof. Ari, yang terhormat Prof. Hegar, Direktur IMERI, yang terhormat para pembicara, Mr. Lian Jackson dan juga Dr. Julian Sham, moderator Dr. Erik Tenda, serta Bapak Ibu, Profesor, Dokter, dan sejawat yang telah mengikuti Zoom pagi hari ini. Senang sekali kita bisa berjumpa di dalam acara Big Data Center pada pagi hari ini. Ini adalah rangkaian acara dari Big Data Center IMERI untuk mendorong supaya beberapa riset yang sangat potensial di lingkungan FKUI dan juga IMERI dan juga di luar dari FKUI dan IMERI untuk bisa menggunakan platform Big Data Center kami untuk bisa mengoptimalkan penelitian-penelitiannya dan sesuai dengan peraturan-peraturan pemerintah, gitu ya. Nah, ini langkah cukup panjang dari kami membuka dalam soft launching di tengah tahun lalu, grand launching di Januari awal tahun ini, dan kami terus mendorong supaya Indonesia dapat mengoptimalkan platform Big Data Center ini. Tidak hanya dari yang peneliti di bidang kesehatan sebagai pemilik data Big Data kesehatan, supaya datanya tidak hanya sebagai data tidur, bisa kemudian sangat produktif. Platform Big Data Center ini juga diperuntukkan untuk peneliti di luar bidang kesehatan yang memiliki metode-metode analisis seperti dari ilmu komputer, teknik, MIPA, dan seterusnya, atau bahkan dari industri yang bisa berkolaborasi dengan peneliti-peneliti di bidang kesehatan untuk bersama menganalisis datanya dan menghasilkan suatu big data analisis yang dapat digunakan juga untuk kebaikan Indonesia, untuk kesehatan Indonesia yang lebih baik. Baik, acara pagi hari ini merupakan kolaborasi antara Big Data Center IMERI-IDEALAB dengan AWS. Jadi AWS adalah platform yang kami gunakan sebagai virtual machine, ya, cloud computing yang ada di belakang layar Big Data Center IMERI-IDEALAB. Maka kami lihat potensinya juga sangat besar. AWS sudah melakukan banyak hal yang sangat positif untuk memajukan kesehatan dengan infrastruktur mereka yang juga sudah sangat luar biasa, tersertifikasi, terstandar, dan yang paling penting juga sudah punya data centernya di Indonesia, di Jakarta. Jadi ini apa yang sudah AWS lakukan nanti kita bisa lihat bersama di paparan dari Pak Leon Jackson dan juga Dr. Julian Shap. Baik, supaya tidak berpanjang-panjang, saya ucapkan selamat mengikuti workshop. Semoga bermanfaat ilmunya dan juga membuka wawasan supaya Bapak Ibu bisa mengoptimalkan big data kesehatan dan juga mengoptimalkan Big Data Center IMERI-IDEALAB untuk penelitian dan inovasi. Akhir kata, terima kasih. Assalamualaikum warahmatullahi wabarakatuh. Saya kembalikan ke Mbak Ina.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih kepada Bapak Sandi atas sambutannya. Kemudian, sambutan kedua disampaikan oleh Direktur IMERI FKUI yang kami hormati Profesor Dr. Badirul Hegar, PhD, SPAK. Kami silahkan.
Baik, terima kasih. Assalamualaikum warahmatullahi wabarakatuh. Yang saya hormati Dekan FKUI, Profesor Dr. Arif Faryal Syam, SPPD KGH MBA, Ketua Big Data Center IMERI FKUI, Prasandhya Astagiri Yusuf, Sarjana Sains Magister Teknik PhD, and our honorable speaker from Healthcare and Life Science Amazon Web Services, Mr. Leon Jackson, and also Dr. Julian Sam. Moderator kita, Dr. Eri Tenda, SPPD, DIC, PhD, Finasin, dan tentunya seluruh peserta webinar. Terima kasih banyak telah hadir pada webinar hari ini. Topik webinar kita pagi ini sangat challenging. Saat ini kita tahu bahwa kompleksitas penyakit meningkat dengan pesat, termasuk terjadinya pandemi COVID-19. Hal ini tentunya menyebabkan tuntutan di bidang kesehatan makin besar dan juga makin berat. Terobosan solusi tentunya sangat diperlukan untuk menghadapi krisis ini. Saat ini kita melihat artificial intelligence atau kecerdasan buatan dan big data menjadi sebuah kemajuan teknologi yang tentunya diharapkan dapat disesuaikan untuk membantu mengatasi kompleksitas masalah kedokteran dan kesehatan yang ada pada saat ini. Bagaimana teknologi berbasis artificial intelligence dan big data ini dapat diimplementasikan untuk membantu para peneliti melakukan berbagai penelitian dan juga bagaimana membantu para tenaga medis menegakkan diagnosis awal atau membantu hal lainnya, misalnya menemukan obat, vaksin, atau hal-hal lain yang mendasarnya. Kita harapkan tentunya artificial intelligence dapat membuat analisis big data menjadi lebih sederhana, baik itu dengan otomatisasi, persiapan dan visualisasi data, pemodelan prediktif, ataupun tugas analitis kompleks lainnya. Dengan memanfaatkan sumber big data, sistem artificial intelligence kita harapkan dapat membuat keputusan yang lebih tepat, memberikan rekomendasi pengguna yang lebih baik, ataupun efisiensi yang terus meningkat. Dan keberadaan Big Data Center IMERI-FKUI menjadi sebuah solusi untuk mengatasi kompleksitas masalah di bidang kedokteran dan kesehatan yang ada pada saat ini. Dan tentunya kita harapkan juga untuk masa yang mendatang. Melalui webinar pada pagi hari ini, kita akan mendapat banyak informasi terkait kedua hal isu tersebut. Karena bersama kita akan ada Ketua Big Data Center IMERI-FKUI dan juga ada teman-teman dari Healthcare and Life Science Amazon Web Services, Asia Pacific and Japan Region. Kita berharap AWS dapat membantu Big Data Center meningkatkan kecepatan inovasi, membuka potensi data kesehatan, dan juga mengembangkan pendekatan yang lebih dipersonalisasi untuk mengembangkan dan perawatan berbagai hal termasuk terapeutik. Untuk itu, saya berharap semoga seminar pagi hari ini akan memberikan inspirasi kepada kita semua dan juga tentunya bermanfaat untuk kita semua di masa yang akan datang. Selamat mengikuti webinar. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih kepada Prof. Hegar atas sambutannya. Berikutnya kita dengar sambutan dari Dekan Fakultas Kedokteran Universitas Indonesia, Profesor Dr. Arifarial Syam, SIPD KGEH MMB, yang sekaligus akan membuka acara pada pagi hari ini. Kami silakan.
Ya. Terima kasih. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Yang terhormat Profesor Dr. Badrul Hegar, anak konsultan PhD, Direktur IMERI-FKUI. Yang terhormat Bapak Prasandhya Astagiri Yusuf, Sarjana Sains, Master Teknologi PhD, Direktur Big Data Center IMERI-IDEALAB. Para pembicara kita hari ini, Mr. Leon Jackson, from Healthcare and Life Science Tech Lead Amazon Web Services Asia Pacific and Japan, and also Dr. Julian Sam, Healthcare Lead Amazon Web Services Asia Pacific and Japan, seluruh peserta webinar NEXT BDC 2022. Alhamdulillah, pertama-tama kita panjatkan puji syukur kepada Allah Subhanahu wa taala, kita semua bisa berkumpul hari ini untuk mengikuti webinar yang sangat penting di era saat ini, di era 4.0, dan akan membahas mengenai pemahaman perlunya teknologi baru seperti artificial intelligence dalam kemajuan big data di bidang kesehatan, sekaligus untuk memperkenalkan platform Big Data Center IMERI-IDEALAB selaku platform pertama yang menyediakan layanan cloud storage, labeling, dan data analytics. Setelah di-launching beberapa saat yang lalu, terus terang saja animo para saintis, khususnya dari institusi pendidikan, cukup tinggi harapannya agar Big Data Center ini bisa segera beroperasi, melakukan kegiatan-kegiatannya ya, operasional sesuai dengan harapan-harapan tersebut. Dan kita mengetahui bahwa IMERI sendiri diresmikan sejak 12 April 2017 dan sudah hampir 5 tahun sejak berdirinya IMERI. Ya, kita bisa melihat berbagai macam penelitian, ya, ratusan penelitian, publikasi, seminar, workshop, conference, ya, dua hal kegiatan-kegiatan utama ya, yang dilakukan oleh IMERI, yaitu Eyes on IMERI, salah satunya. Dan ini tentu memberikan harapan yang positif kepada kita semua untuk bagaimana memanfaatkan IMERI-FKUI ini sebaik-baiknya sebagai suatu pusat penelitian dan bermanfaat untuk kita semua. Dan tentu dengan keberadaan Big Data Center ini juga memperkuat lagi IMERI sebagai suatu pusat penelitian. Nah, di satu sisi kita mengetahui bahwa IMERI ini dibangun berdasarkan hibah dari Islamic Development Bank, IDB, dan beberapa waktu yang lalu Presiden IDB sempat hadir ke IMERI dan melihat langsung pencapaian-pencapaian yang telah dihasilkan, dan beliau mengapresiasi bahwa dalam 5 tahun ini begitu besar perkembangan yang telah dilakukan IMERI dengan berbagai macam kegiatannya. Oleh karena itu, pada kesempatan ini kami berharap setelah webinar ini, kita mendengarkan 2 pembicara ini dari Amazon Web Services, akan memperkuat lagi Big Data Center dan juga lebih meningkatkan motivasi teman-teman para peneliti untuk menitipkan data-datanya di sini, dan tentu nanti bisa berinteraksi dengan para peneliti yang memang berminat untuk melakukan riset-riset selanjutnya dari data-data yang telah di-upload di Big Data Center ini. Kepada para panitia dan teman-teman dari Big Data Center dan juga teman IMERI, saya mengucapkan terima kasih atas upaya-upaya yang terus dilakukan untuk bagaimana IMERI ini bisa benar-benar bermanfaat untuk kita semua. Lebih dan kurangnya saya mohon maaf. Wabillahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih pada Prof. Ari yang telah memberikan sambutan dan secara resmi membuka acara ini. Baik, berikutnya adalah dokumentasi foto. Dipersilakan kepada operator untuk men-spotlight dan dapat memandu sesi dokumentasi kali ini. Pada operator, kami silakan.
Hanya berdua nih yang pasang video mungkin ya.
For Mr. Leon Jackson and Dr. Julian can open cam.
Oh. Oh,
Hi.
Mr. Leon Jackson.
Good morning.
Good morning, Dr. Julian Sham.
Morning. Okay, we can start to make a picture.
Kepada operator, kami persilahkan untuk memandu.
Ya, akan diambil foto dalam 1, 2, 3. Ya, sudah.
Terima kasih kepada Bapak Sandi, Bapak Prof. Hegar, dan Prof.
Hegar.
Ari yang telah menyempatkan untuk memberikan sambutan dan membuka acara hari ini. Berikutnya adalah sesi materi yang pertama. Narasumber yang pertama ini merupakan ketua dari Big Data Center IMERI-IDEALAB sendiri, Bapak Prasandhya Astagiri Yusuf, SSI, MT PhD. Selamat pagi, apa kabar Bapak Sandi?
Baik, gimana Mbak Indah kabarnya?
Baik, alhamdulillah Pak. Nah, durasi pemaparan materi kurang lebih 30 menit ya Pak, dan Bapak Ibu hadirin dapat mengajukan pertanyaan melalui kolom chat dengan format nama, _instansi, _pertanyaan. Pertanyaan akan ditampung dan dijawab saat sesi tanya jawab. Baik, kepada Bapak Sandi kami persilahkan.
Baik, terima kasih Mbak Indah. Sekali lagi Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi, salam sejahtera, salam sehat. Prof, Dokter, Bapak, Ibu semuanya, luar biasa sekali di hari Sabtu, long weekend di tengah puasa gitu. Saya lihat animonya tetap tinggi. Saat ini sudah 52 partisipan yang bergabung di dalam Zoom. Dan secara statistik ini juga tadi saya harusnya sampaikan di awal ya, tapi mumpung saya jadi pembicara lagi. Ada sampai 94 orang yang register di acara Zoom pagi hari ini, dan ada dari 48 orang dari universitas, 20 dari lingkungan FK UI dan IMERI, dan 22 dari rumah sakit. Jadi saya rasa ini acara yang sangat baik. Terima kasih banyak atas partisipasinya. Semoga bisa bermanfaat untuk kita semua. Izinkan saya di sesi awal saya akan paparkan dulu sedikit terkait apa Big Data Center IMERI dan bagaimana peluangnya untuk bisa membantu penelitian Bapak dan Ibu yang banyak meneliti di bidang kesehatan ya, terutama. Oke, bisa tolong bantu di share screen? Ya. Paparan ini nanti akan kami sampaikan juga setelah acara selesai, email Bapak Ibu sekalian. Oh ya, kita akan sampaikan dalam bahasa Indonesia dulu ya. Nanti sesi materi kedua baru akan dipandu dalam bahasa Inggris. Baik, next. Saya perlu menyampaikan lagi terkait apa itu Big Data Center IMERI-IDEALAB. Jadi ini adalah suatu platform yang dibangun kolaborasi dari IMERI, Indonesian Medical Education and Research Institute, di bawah pimpinan Prof. Berdiul Hegar, dan juga perusahaan yang disebut UMG-IDEALAB, di bawah pimpinan Pak Kiwi Aliwarga. UMG-IDEALAB adalah satu perusahaan venture capital yang menyuntikkan dananya, memiliki visi yang sama untuk kemudian menyuntikkan dana pembangunan Big Data Center ini. Kenapa kami membangun? Kami lihat banyak sekali penelitian, banyak sekali pengumpulan data kesehatan, tapi kok masih scattered gitu ya, masih belum terfasilitasi, belum pernah ada Big Data Center kesehatan di Indonesia untuk memfasilitasi ini. Dengan visi, berangkat dari visi yang sama, kami membangun Big Data Center ini, harapannya bisa untuk memfasilitasi semua penelitian kesehatan yang membutuhkan storage, pelabelan, sampai ke analisis di platform yang sama. Oke, next. Perjalanan panjang pembangunan Big Data Center IMERI sejak tengah tahun lalu kami sudah soft launching, lalu grand launching di akhir Januari kemarin, dan sekarang masih terus dikembangkan untuk memenuhi kebutuhan dari Bapak Ibu peneliti. Next. Tagline kami adalah One Stop Solution. Sehingga Big Data Center IMERI itu adalah suatu platform berbasis komputasi awan yang tidak hanya untuk penyimpanan data, tapi juga bisa untuk melakukan katalogisasi data, bisa untuk pelabelan data, sampai ke analisis data di satu platform yang sama. Next. One Stop Solution ini fitur-fitur utamanya adalah tentunya akan ada single sign-on untuk bisa login, kemudian bisa untuk melakukan penyimpanan data di cloud storage, bisa untuk dilakukan katalogisasi data, data katalog, bisa untuk data labeling, tentunya billing system, tergantung apa yang Bapak Ibu langgan, dan di akhir adalah sampai ke cloud computing analytics, lakukan penelitian atau analisis dengan komputasi, misalnya dengan pemodelan AI dan lain-lain, untuk menganalisis big data yang sudah dikumpulkan. Next. Ya, kami sangat aware dan juga mementingkan terkait data security dan data protection. Jadi, acara ini adalah salah satu upaya kami untuk membuka wawasan juga Bapak Ibu bahwa tidak selalu penyimpanan data secara fisik itu ternyata aman. Ya. Jadi, ada peluang seperti hardware failure, human error, social engineering, natural disaster, yang mungkin mengancam jika penyimpanan data masih secara konvensional, secara fisik. Ini juga sama jika memiliki server secara fisik on-premise, ini juga selain biaya yang sangat-sangat besar, ancaman-ancaman tadi juga nyata. Ya. Berangkat dari latar belakang tersebut, kami berkolaborasi dengan AWS sebagai penyedia layanan virtual machine berbasis cloud untuk pembangunan platform Big Data Center IMERI-IDEALAB. Selanjutnya terkait data governance, ini juga sangat penting di mana ketika data kesehatan ini tidak sama dengan data-data yang lain. Big data itu adalah katanya new oil. Nah, big data kesehatan ini nilainya tidak terhingga. Gitu ya. Jadi terkait juga dengan ketahanan suatu negara. Jadi kami mengatur dalam sistem data governance di mana data owner selalu dan akan selalu menjadi pemilik dan punya kuasa penuh terhadap data tersebut. Diletakkan di IMERI, diletakkan di Big Data Center IMERI-IDEALAB, bukan berarti kemudian yang lain bisa melihat. Gitu ya. Jadi kami di IMERI, dari IDEALAB, dari tim developer, AWS, pihak ketiga lainnya, tidak ada yang dapat mengakses data yang diletakkan. Jadi ini terkunci dengan SSO. Oke, terkait Board of Data Governance, saya akan sampaikan di slide selanjutnya. BOD IMERI dengan Big Data Center IMERI sudah mencoba menyusun data governance untuk Big Data Center kami. Di sini kami sudah coba masukkan beberapa hal, misalnya Big Data Center IMERI ini adalah tempat untuk bisa menyimpan bank data, biorepository dari layanan, pendidikan, penelitian, pengemas, di bidang kesehatan. Lalu data yang tersimpan sudah mendapatkan general informed consent dari pasien yang diperiksa. Penelitiannya sudah mendapatkan ethical clearance. Kemudian datanya tetap milik tim peneliti, yang kemudian untuk menyimpan data, itu ada pilihan selalu dikembalikan ke pemilik data, apakah mau dibuat sebagai public atau restricted. Public restricted ini adalah opsi untuk bisa mengkatalogisasi data. Orang yang sudah bisa masuk ke Big Data Center IMERI bisa mengintip, tanda kutip melihat gitu ya, oh ternyata peneliti A punya ribuan data kesehatan. Nanti bisa dibuat atau diarahkan ke kerjasama penelitian dari data tersebut. Atau Bapak Ibu peneliti juga bisa set sebagai private. Tidak bisa dilihat oleh orang lain, hanya bisa dilihat oleh peneliti saja. Melalui AWS, dengan sistemnya tentunya data akan aman dan juga terbackup secara berkala, sehingga data yang diletakkan bisa dijamin. Lalu authorship dari publikasi, jika nanti hasilnya akan dipublikasikan, ada ketentuannya, kami letakkan di sana. Lalu kami juga akan memiliki yang disebut Data Governance Board. Jadi dari dekan, direktur rumah sakit, steering committee, dan seterusnya, tim pakar, yang ini akan mengatur terutama terkait penelitian-penelitian multidisiplin, lintas center, sehingga akses data, sharing, kolaborasi, authorship, dan lain-lain nanti bisa dibantu, dimediasi oleh Data Governance Board ini. Oke, baik, kita lanjut dulu. Ya, ini adalah peraturan-peraturan pemerintah yang kami sengaja tampilkan, kami aware, dan kami aplikasikan di dalam platform kami, yaitu tentang sistem informasi kesehatan yang penyimpanan data kesehatan harus ada di dalam negeri. Oleh karena itu kami kerjasama dengan AWS yang sudah memiliki data center mereka di Indonesia. Lalu rancangan perlindungan data pribadi, ya, itu sudah kami buat keamanan berlapis untuk Big Data Center ini, rahasia kedokteran juga, serta Undang-Undang ITE. Jadi semoga dengan seperti ini Bapak Ibu tidak perlu ragu apakah Big Data Center IMERI sudah memperhatikan regulasi-regulasi yang berlaku di Indonesia. Next. Sangat penting karena Big Data Center IMERI-IDEALAB ini adalah untuk menyimpan data kesehatan. Kami telah membuat suatu pertemuan dengan Digital Transformation Office Kementerian Kesehatan supaya bisa ada kolaborasi dan juga pemanfaatan yang baik BDC IMERI ini bisa digunakan juga di lingkungan Kementerian Kesehatan, berkolaborasi dengan rumah sakit yang ada di bawah Kementerian Kesehatan. Next. Ya, terkait layanan Big Data Center IMERI-IDEALAB, setelah Bapak Ibu register, platformnya tadi sudah ada tautannya ya, bisa dicoba, silahkan register bagi yang belum. Nanti ada pilihan untuk subscribe, maka bisa dipilih data storage, labeling, dan analytics. Ketika menyimpan data atau data storage, tadi saya sudah sebutkan, bisa dipilih sebagai data katalog, yaitu public atau restricted, atau private, di mana hanya Bapak Ibu saja yang pemilik data bisa melihat. Tidak bisa dilihat oleh orang lain. Next. Terkait single sign-on, ini yang akan tampil ketika Bapak Ibu registrasi di platform Big Data Center kami. Next. Jika sudah subscribe, maka bisa masuk dan bisa mendapatkan akses untuk memilih cloud storage dan data katalog ya. Coba next, saya akan berikan gambaran. Tadi saya sudah sebutkan ada public, restricted, dan juga private. Ini dikembalikan ke peneliti, pemilik data, bebas mau di-share sebagai apa. Gitu ya. Di-share atau dikunci sebagai private. Kalau di-set sebagai public, maka orang yang register atau sudah subscribe ke dalam Big Data Center IMERI, itu bisa melihat dan mengakses data yang Bapak Ibu simpan. Ini sudah tidak asing lagi karena kita tahu ada Kaggle dan repositori data yang lain yang dibuka untuk umum gratis untuk bisa ada penelitian terkait big data kesehatan. Tapi yang kami dorong sebenarnya yang kedua, tipe restricted. Kenapa demikian? Karena restricted ini sama data katalog, artinya orang luar bisa melihat list dari data Bapak Ibu yang disimpan di Big Data Center IMERI, tapi hanya bisa diakses kalau diberikan persetujuan oleh pemilik data. Jadi kalau ada pihak ketiga yang melihat, oh ternyata misalnya di sini ya contohnya adalah Prof. Iko yang sudah menyimpan ribuan data embrio, ya ini sangat potensial bisa dianalisis menggunakan AI misalnya. Lalu ada peneliti, seorang engineer melihat ini sangat potensial menghubungi pemilik data melalui Big Data Center untuk mengakses. Nanti akan dibuat suatu perjanjian kerjasama yang juga memagari dan juga melindungi hak-hak dari pemilik data. Karena kita tahu bersama pengumpulan data kesehatan itu butuh biaya yang sangat besar. Jadi terkait intellectual property, terkait publikasi, dan juga mungkin rencana komersialisasi ini bisa diatur dalam PKS tersebut. Yang berikutnya private. Private ini sekali lagi adalah data yang tidak bisa dilihat oleh orang luar kecuali pemilik datanya. Semoga cukup jelas. Next. Ya, fitur berikutnya adalah data labeling. Ketika kita punya big data dan kita akan menggunakan AI untuk membantu melakukan analisis, maka AI ini tidak lebih pintar dari manusia, dia perlu diajari pattern-pattern yang kemudian pada akhirnya nanti mereka bisa secara otomatis melakukan kategorisasi atau mungkin prediksi. Nah, data labeling ini bisa dilakukan di dalam platform Big Data Center IMERI tanpa perlu mengunduh lagi, dan seterusnya bisa di satu platform yang sama. Pelabelannya juga bisa macam-macam, bisa untuk data image seperti yang tampil di sini, contohnya data chest X-ray yang dilabel satu persatu, contohnya ini adalah penelitian TB gitu ya. Lalu bisa data video, data audio, dan juga data tabel atau data tabular. Ini nanti bisa dilakukan pelabelan di platform kami. Ketika sudah dilabel, maka selanjutnya Big Data Center IMERI bisa membantu melakukan computing analytics. Nah, tentunya kalau Bapak Ibu punya resource-nya, silahkan bisa menggunakan langsung di Big Data Center. Kalau misalnya butuh bantuan, kami juga ada service untuk melakukan analisis data tersebut di platform kami. Next. Ya, Big Data Center IMERI tadi sudah disebutkan kolaborasi dengan AWS ya, sebagai penyedia layanan cloud computing. Oleh karena itu ada suatu biaya juga yang perlu dibayar atau dilanggan oleh Bapak Ibu peneliti. Namun saya rasa biayanya juga tidak terlalu besar ya. Contohnya di sini single sign on, ada bisa pilihan per bulan atau per tahun. Data storage dari yang paling kecil 100 GB, saya rasa juga terjangkau 60.000 per bulan, sampai ke yang paling tinggi misalnya 10 TB bisa 4,6 per bulan, dan ini ada kelipatannya ya, misalnya 200 GB jadi 2 kali 60.000 dan seterusnya. Tergantung kebutuhan Bapak Ibu. Yang di sebelah kanan adalah simulasi big data kesehatan. Apakah Bapak Ibu punya data tabular, audio, image, atau video, sehingga bisa membayangkan kebutuhan saat ini dan kebutuhan jangka menengah, jangka panjang gitu ya. Jadi bisa memetakan, oh berarti saya butuh data storage sekian untuk menyimpan data big data kesehatan saya. Selanjutnya data labeling, ini hitungannya per jam, tergantung kompleksitas dari data yang akan dilabel. Data labeling akan bekerja sama dengan expert yang melakukan pelabelan. Misalnya tadi data chest X-ray, ya tentunya expertnya adalah tim radiologi toraks gitu. Atau data embrio tentunya nanti mungkin dokter-dokter obgyn yang akan membantu. Berapa jam kebutuhan data labeling nanti akan dihitung, akan diberikan gambaran ke Bapak Ibu jika ada kebutuhan data labeling, nanti setelah disepakati baru bisa dibayar dan kemudian bisa lanjut prosesnya. Big data consultation, ini juga penting, mungkin Bapak Ibu belum terbayang apa sih yang harus saya siapkan, bagaimana meng-cleaning data dan seterusnya. Ini kami menyediakan konsultasi big data. Dan setelah kemudian siap untuk dianalisis, kami juga sediakan dua hal ya. Pertama, computing service, yang ini juga menggunakan cloud computing dari AWS, yang tempat big data center kami ini berdiri. Nah, ini juga tergantung datanya, bisa data tabular, image, audio, video, dan teks. Dan jika Bapak Ibu membutuhkan tenaga ahli untuk bisa melakukan analisisnya, kami juga ada tenaga-tenaga ahli yang bisa membantu, dan ini satuannya per jam. Dalam pembayaran kami sangat mencoba memudahkan, bisa menggunakan transfer, sampai menggunakan payment gateway ya dari IP. Oke, next. Ini ada beberapa gambaran jika misalnya peneliti memiliki chest X-ray contoh tadi ya, ada 1.500 data tapi tidak tahu mau diapakan gitu ya, belum ada yang bisa menganalisis, maka bisa bekerja sama dengan Big Data Center, bisa subscribe, kemudian memilih cloud storage-nya, bisa untuk konsultasi big datanya, dan kemudian pelabelan data. Misalnya, oh ternyata 1.500 data ini butuh 6 jam, jadi 500.000 kali 6 kurang lebih. Lalu data analytics, oh ternyata untuk analisis data ini butuh sekian jam total. Ini nanti akan ada perhitungannya tergantung kompleksitas data. Next. Ini juga bisa digunakan misalnya pada rumah sakit yang punya data kesehatan yang sangat besar, dikolaborasikan, terserah apakah sebagai data katalog atau hanya untuk penyimpanan data, untuk backup datanya saja. Untuk jika misalnya data katalog, maka ada peneliti dari ilmu komputer misalnya melihat, oh rumah sakit A punya data yang luar biasa, saya mau kerjasama untuk menganalisis data tersebut. Gitu ya. Jadi itu manfaatnya untuk rumah-rumah sakit yang punya big data kesehatan untuk bisa mengkatalogisasi big data mereka di dalam big data center ini untuk membuka peluang kerjasama dengan pihak ketiga. Next. Selanjutnya adalah dari pihak orang yang punya tools untuk menganalisis tapi tidak punya datanya. Ini yang terjadi di Indonesia secara real. Gitu ya. Sulit sekali orang-orang dari ilmu komputer, teknik, IMIPA gitu untuk mengakses big data di bidang kesehatan. Oleh karena itu, Big Data Center IMERI ini diharapkan bisa menjadi platform tempat bertemunya pihak-pihak tersebut. Di sini seorang ilmuwan dari ilmu komputer ingin menganalisis data dan semua bisa dilakukan juga di platform Big Data Center IMERI ini tanpa dia harus mengunggah lagi ke tempat lain misalnya, atau dia lakukan tidak perlu punya high performance computing untuk melakukan analisis, bisa dilakukan secara cloud computing di platform kami. Next. Ya, kami ada beberapa promosi, beberapa masih dalam proses. Ketika Bapak Ibu subscribe, maka nanti semoga dalam waktu dekat ya, di akhir April ini, langsung otomatis diberikan akses free trial 1 GB untuk 1 bulan, sehingga bisa mencoba dulu, oh kira-kira ini bermanfaat, cocok atau tidak ini untuk penelitian saya. Kemudian kalau misalnya yakin, kemudian bisa subscribe untuk storage. Untuk penelitian-penelitian yang terpilih, ini bisa diajukan untuk mendapatkan free trial 3 bulan gratis untuk 100 GB. Ini juga saya rasa sangat membantu sekali. Dan ini tapi promosinya terbatas, silakan bisa menghubungi tim kami. Next. Ya, Big Data Center IMERI-IDEALAB tidak akan bisa berdiri atau berjalan tanpa dukungan banyak sekali pihak, tentunya dari IMERI maupun dari IDEALAB. Dan ini adalah pihak-pihak yang bergabung, di antaranya Prof. Budi Wiweko, Pak Kiwi, saya sebagai ketua, lalu ada Pak Satrio, Dr. Ali, Dr. Arya Kekali, Dr. Erik Tenda, Dr. Rehan, Bu Fadila, Dr. Irzan, Dr. Nino, dan seluruh tim yang sangat-sangat membantu luar biasa untuk menjalankan operasional Big Data Center IMERI-IDEALAB ini. Next. Bapak Ibu bisa berkontak, bisa melihat media sosial kami dan berkontak langsung ke tim kami untuk mendapatkan informasi lebih lanjut. Semoga Big Data Center IMERI-IDEALAB bisa memiliki manfaat yang besar untuk penelitian Big Data kesehatan di Indonesia. Saya cukupkan. Terima kasih banyak. Assalamualaikum warahmatullahi wabarakatuh. Saya kembalikan ke Mbak Indah.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih atas pemaparan materinya. Sangat menarik materinya ya, Pak. Selanjutnya, kita membuka sesi pertanyaan dengan durasi 15 menit. Sesi tanya-jawab pertama akan dibatasi 3 pertanyaan terlebih dahulu. Dipersilahkan untuk para audiens untuk bertanya dengan format nama, _instansi, _pertanyaan. Kepada audiens dipersilahkan. Mungkin selagi menunggu pertanyaan dari audiens, saya sendiri ingin bertanya nih terkait Big Data Center IMERI-IDEALAB. Pertanyaan dari saya, jika saya peneliti telah mempublish data saya ke Big Data Center, namun di bulan berikutnya saya lupa untuk berlangganan kembali, mensubscriptionkan kembali, itu data saya akan dihapus atau adakah konfirmasi dari Big Data Center?
Ya, terima kasih Mbak Indah. Ini sering kali ditanyakan ya. Jadi jika Bapak Ibu sudah menyimpan data di Big Data Center IMERI, tentunya datanya Big Data tidak mungkin lebih dari 1 giga ya, pasti ya. Nah, saya rasa ini data yang sangat penting juga untuk Bapak Ibu. Kalau misalnya ternyata nanti ada miss yang belum terbayar atau apapun, kami tidak otomatis langsung hapus, akan diberikan 30 hari grace period istilahnya, dan kami akan mengingatkan kembali ke Bapak Ibu peneliti sebagai pemilik data apakah mau berlanjut atau tidak. Setelah 30 hari, maka data itu baru dihapus, gitu ya. Dan data ini sekali lagi tidak bisa kami akses. Kalau misalnya ternyata tidak digunakan, tentunya akan langsung dihapus tanpa kami bisa melihat isinya apa. Sudah terjawab ya, Mbak Indah?
Iya, betul Pak Sandi. Berarti user tidak perlu khawatir ya Pak tentang keamanan data, dan pastinya data yang telah disimpan jika subscription-nya habis tidak langsung dihapus, namun ada konfirmasi terlebih dahulu 30 hari ya Pak tenggat waktunya.
Betul sekali. Ini satu sedikit tambahan, kalau tadi saya sampaikan ada free trial 1 GB ya, Mbak Indah promosi. Ketika subscribe, maka akan diberikan akses 1 GB untuk free. Nah, kalau ini setelah 30 hari, Pak Ibu tidak subscribe, maka otomatis hilang ya, karena ini adalah free trial. Tapi kalau sudah membayar, dan kemudian lupa memperpanjang atau ada satu dan lain hal, itu kami berikan grace period 30 hari.
Baik Pak Sandi, sangat menjawab pertanyaan saya. Oke, baik, kita kembali ke audiens. Berikut ada dari Dr. Rina bertanya, bagaimana memastikan bahwa data kita betul-betul secure? Apakah ada indikator yang kita bisa lihat? Mungkin Pak Sandi bisa menjawab. Terima kasih.
Ya, baik, terima kasih. Nanti kita bisa ulik juga lebih jauh ya, karena kita semua nanti akan mendengarkan sumber dari AWS, bagaimana sistem AWS memiliki security atau keamanan data yang sangat tinggi. Jadi Big Data Center ini pertama ada suatu login di mana tidak ada yang bisa mengakses data yang disimpan kecuali punya password-nya, gitu ya. Nah, jadi keamanan data ini sebenarnya ada dua. Ketika sudah diunggah ke dalam Big Data Center IMERI-IDEALAB, maka tanggung jawabnya ada dua ya, dua pihak. Pertama, kami di Big Data Center, dan juga mungkin AWS sebagai penyedia platform virtual machine-nya. Yang kedua adalah pihak Bapak Ibu peneliti yang menyimpan data. Karena seringkali ini kita juga kadang menemui seperti ini ya, username dan password disebar kemana-mana gitu ya. Jadi silahkan bisa gunakan ini untuk mengunggah data, mengakses data. Nah, tidak sengaja ini tersebar kemana-mana ke pihak lain yang mungkin tidak bertanggung jawab atas seterusnya, sehingga ada kebocoran data misalnya. Nah, ini tentunya akan dilihat case by case. Tapi kalau dari sisi kami, Big Data Center IMERI, kami memiliki jaminan security datanya berlapis, tidak ada orang lain yang bisa mengakses kecuali punya username password. Nanti kita akan bisa lihat juga di materi yang kedua dari AWS. Tapi dari sisi user juga penting sekali menjaga kerahasiaan dari username dan password-nya. Dibagi secara terbatas ke orang-orang. Kalau misalnya mau dibagi, orang-orang terbatas gitu ya, jangan misalnya disebarkan secara meluas, kemudian nanti akhirnya ada orang yang bisa mengakses yang tidak memiliki kewenangan, misalnya seperti itu. Nanti secara teknis kita akan bisa jawab di sesi kedua nanti ya Mbak Indah. Terima kasih Dr. Rina pertanyaan.
Baik, terima kasih jawabannya Bapak Sandi. Berikutnya ada pertanyaan dari Ibu Novita Hasrianti. Untuk pengguna Big Data, siapa saja yang boleh, dokter? Apa semua dokter di Indonesia boleh, atau mahasiswa, atau ada syarat-syarat khusus dalam penggunaan atau penyimpanan data ini?
Baik, terima kasih atas pertanyaannya, Bu Novita. Ini terbuka untuk semua ya. Memang judulnya ini adalah Big Data Center IMERI-IDEALAB. Tapi tidak hanya di lingkungan IMERI atau FKUI. Ini terbuka untuk nasional. Jadi silahkan bagi yang tertarik untuk yang menyimpan data, mengkatalogisasi data, atau bahkan yang tertarik untuk mencari data-data apa sih yang ada di BDC IMERI yang bisa dikerjasamakan misalnya. Itu juga bisa. Jadi ini tidak terbatas di lingkungan UI saja. Dan seluruh dokter di Indonesia tentunya boleh. Dan syarat-syarat khusus pengguna data atau penyimpan data itu sebenarnya tidak ada. Jadi siapapun boleh. Tapi kami nanti bisa memberikan arahan-arahan kalau dikatalogisasi atau bisa dibuka, maka IMERI-IDEALAB dapat memberikan informasi atau arahan gitu ya, bahwa big data yang disampaikan itu jangan big data asal big data tanda kutip, tapi big data yang sudah siap untuk bisa di-share, sehingga nanti orang kemudian bisa tertarik untuk kerjasama. Gitu. Kalau datanya hanya mengandalkan big data, tapi kemudian banyak bolong datanya atau tidak lengkap atau belum memenuhi ketentuan tertentu, belum dianonimisasi atau apapun, itu kemudian belum layak di-share atau dikatalogisasi sehingga bisa dilihat oleh orang lain. Semoga menjawab. Jika masih ada pertanyaan boleh disampaikan lagi.
Baik, terima kasih atas jawabannya Pak Sandi. Mungkin tadi untuk sesi pertama dalam menjawab pertanyaan. Saya beri kesempatan kembali untuk sesi kedua untuk audiens bertanya. Dari audiens dipersilakan untuk bertanya di kolom chat. Mungkin belum ada dari audiens. Bolehkah saya bertanya lagi nih Pak Sandi?
Boleh, silakan Mbak Indah.
Untuk penyimpanan data ini ada kapasitas maksimalnya nggak sih Pak Sandi untuk publikasinya?
Ya, baik. Ini pertanyaan juga sering ditanyakan Mbak Indah. Terima kasih. Jadi memang dalam Big Data Center IMERI-IDEALAB ini kerjasama dengan AWS, dan AWS yang kami langgan ini adalah pilihannya pay as you go. Jadi yang kami gunakan itu yang dibayar, sehingga kalau misalnya dibutuhkan, saya butuh 1 tera, 2 tera, 10 tera, 20 tera gitu ya, terabyte maksud saya ini, itu silahkan AWS akan menyediakan. Jadi tidak dibatasi, satu orang maksimal 10 terabyte ya, jangan lebih. Nah, itu tidak ada seperti itu. Silahkan kalau misalnya kebutuhan datanya besar, maka nanti AWS yang akan menyiapkan, dan Bapak Ibu tinggal melanggan dan juga subscribe berdasarkan pilihan dari storage yang dipilih. Seperti itu Mbak Indah.
Berarti mau berapapun storage yang diperlukan itu pasti ada dan disiapkan oleh server yang ada ya Pak. Sangat menarik
betul.
untuk.
Itulah keuntungannya untuk cloud computing ya. Kalau kita punya server fisik, maka ada keterbatasan storage-nya. Kita punya let's say 100 terabyte gitu ya, maka tidak akan bisa lebih dari itu kecuali di-upgrade. Nah, dengan adanya cloud computing ini, saya rasa sangat-sangat membantu untuk bisa memfasilitasi kebutuhan data yang terus meningkat. Kemudian juga big data, datanya terus meningkat.
Iya, betul sekali nih. Untuk para user nanti mengganti dari physical storage ke cloud storage, yaitu pastinya di Big Data Center IMERI-IDEALAB ya. Baiklah, kembali ke audiens. Ini ada pertanyaan. Untuk yang free trial, apakah termasuk fitur cloud computing? Jika iya, berapa max memori yang diallocate untuk cloud computing? Terima kasih. Silakan Pak Sandi.
Oke, baik. Terima kasih Mbak Indah. Terima kasih Bu Gracia. Jadi untuk yang free trial, ini belum termasuk cloud computing ya. Jadi baru cloud storage-nya saja. Apakah nanti bisa ada? Memungkinkan ada, tapi saat ini belum gitu ya. Jadi kami karena ini kali pertama ada big data center di Indonesia, jadi kami juga memiliki perencanaan-perencanaan jangka pendek dan juga jangka menengah, jangka panjang. jangka panjangnya nanti kami juga bisa membuat seperti ini. Jadi pengguna yang dari sisi ilmu komputer, teknik itu juga bisa mencoba dulu gitu ya. Mungkin kalau boleh ada bandingannya seperti Google Colab gitu, itu kan juga ada versi gratisnya dulu sehingga bisa dicoba. Kalau lebih dari kapasitas tertentu atau dari waktu tertentu maka itu harus bayar. Itu nanti bisa kami sematkan. Tapi saat ini sementara belum, Bu. Terima kasih sudah ditanyakan.
Baik, terima kasih Pak Sandi atas jawabannya. Baiklah, karena durasi waktu tinggal sedikit lagi, pertanyaan tersebut merupakan penutup di sesi materi pertama ini. Dari materi ini dapat disimpulkan bahwa Big Data Center dapat sebagai wadah Big Data kesehatan yang dapat memfasilitasi penelitian data kesehatan. Yang pastinya data kesehatan tersebut dapat dimanfaatkan dalam perkembangan computing data analitik yang dapat membantu dalam pelayanan kesehatan baik diagnostik maupun terapeutik. Dan para user tidak perlu khawatir akan keamanan data karena server AWS yang digunakan itu berada di Indonesia dan mengikuti peraturan dari pemerintah terkait data kesehatan. Dan data yang telah dipublikasikan diberikan tenggat waktu sebelum dihapus, yang kata Pak Sandi tadi 30 hari. Cukup lama kan? Oke, terima kasih Pak Sandi atas materinya yang sangat informatif.
Sama-sama, semoga bisa bermanfaat.
Baik, semoga bisa bermanfaat untuk kemajuan Big Data kesehatan di Indonesia. Baiklah, Bapak Ibu hadirin, sebelum dimulainya materi kedua pada hari ini, saya akan perkenalkan terlebih dahulu moderator kita yang akan memandu materi kedua hari ini. Beliau adalah Dr. Erik Daniel Tenda, SPPD DIC, PSD Pinasim. Beliau memiliki latar pendidikan dokter di Universitas Samratulangi pada tahun 2002. Beliau kemudian melanjutkan pendidikan spesialis ilmu penyakit dalam program pendidikan dokter spesialis ilmu penyakit dalam Universitas Indonesia dan lulus pada tahun 2013. Dr. Erik merupakan dosen pendidik klinis di program studi ilmu penyakit dalam FKUI dengan jabatan fungsional saat ini adalah asisten ahli. Beliau pakar dalam bidang kekhususan pulmonologi dan tercatat sebagai staf di Divisi Respirologi dan Penyakit Kritis, Departemen Ilmu Penyakit Dalam FKUI RSCM. Beliau juga merupakan Head of Artificial Intelligence and Digital Health Research Group, IMERI. Untuk itu, Bapak Ibu hadirin, mari kita sambut moderator kita, Dr. Erik Daniel Tenda.
Halo, Assalamualaikum. Mbak Indah, terima kasih.
Waalaikumsalam. Selamat pagi, Dr. Erik.
Selamat pagi.
Kami persilakan untuk memandu materi kedua, Dok.
Baik. So untuk sesi selanjutnya saya akan memimpin dalam bahasa Inggris ya, karena kita ada dua speaker ya. Oke. Alright. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Very good morning to everyone. First of all, I would like to say big congratulations to Big Data Center IMERI-IDEALAB for this lovely event, even though this is a weekend. And probably half of the participants, or probably most of the participants, we are currently fasting. But I'm hoping that this fruitful discussion will actually energize us to actually discuss more about the new inventions from FKUI IMERI, which is the big data center by IMERI-IDEALAB. So without any further ado, I would like to actually introduce our two speakers for this second session. All right. So first, we will have Mr. Lian Jackson. So hello, Lian. Thank you for attending this webinar. So Lian Jackson is from AWS. He's a healthcare and life science tech lead in Asia Pacific, Japan, from Amazon Web Service. Lian Jackson is a healthcare life science tech lead, as I already mentioned, and he came to Stratic from CIO job in healthcare with 16 years of experience in software engineering and 10 years of direct experience in healthcare. So I think many things that Leon can share with us about the service provided by the AWS. And for the second speaker for today, we'll have Dr. Slide, please. Dr. Julian Sham. Hello, Julian. Thank you for attending this meeting. So Dr. Julian Sham is a healthcare led for Asia Pacific and Japan, AWS or Amazon Web Services. Dr. Julian Sham brings more than 32 years of experience in healthcare to these roles, including more than 10 years of practicing hospital doctor. He is passionate about how healthcare delivery can be augmented through cloud and health technologies, improving clinical engagement and stakeholders' understanding to accelerate clinical solution design life cycles. So yes, without any further ado, actually, I will give the first stage to Dr. Julian Sham.
Thank you very much, Dr. Eric. Selamat pagi, everybody.
Good morning. Very good morning to you. Selamat pagi.
So I'm going to share some slides. So give me a moment.
Yes, please.
Moderator, if you can give me permission to share slides, I can start going through the deck. Awesome. Okay. So as I'm letting the technology do its business, I just wanted to say thank you very much to IMERI-IDEALAB for inviting Leon and myself to speak to this lovely panel. I want to congratulate IMERI because I think it was about a year and a half ago that myself and the team were invited to speak to Professor Dr. Budi Werko, and he asked us, why does AWS work in health and what do you do? Very kind of initial question. So at that time, we kind of explained to him what we do in healthcare and how our teams operate with our customers in healthcare research and life sciences around the world. And it's great to see that now in Indonesia, you have the big data center, you have the EKE UI, you have IMERI established. And I just wanted to say to my team, the AWS Indonesian team, who have been working very, very hard in the background to ensure that the needs are met. Well done to you guys. So thank you for your hard work. What I'd like to do today in the next 45 minutes is Leon and I really kind of share a little bit about what AWS does in health, how that applies to big data center and IMERI, and how you as stakeholders and collaborators in this space can potentially look at how some of these technologies that are hosted on cloud can enable you to answer the science and the healthcare questions, and using BDC and AWS support to make sure that the technology in the background supports what you need to do. Leon will then actually go deep dive into a little bit more information about where we're seeing some of the cloud kind of horizon technologies are being looked at elsewhere around the world. And hopefully this will stimulate some thinking and not create a limitation for what the collaborators, the stakeholders and BDC can hopefully achieve in the future with the data, the big data that you hopefully collect, the insight you can generate, and how that can help solve clinical and healthcare problems that we see around the world. So just a quick brief background about AWS. Those of you that don't know, Amazon Web Services, we're a cloud platform provider. What that means is that the storage and applications that you potentially use in the old days that may be on a computer under your desk, you're now able to run many of that over an internet connection. And as was presented earlier on, potentially being charged in a kind of software as a service manner. In healthcare specifically, AWS, we've had a dedicated healthcare and life sciences team internationally for more than 8 years. And on average, the people that you would talk to, my colleagues, we have 18 years of healthcare industry, ranging from chief digital officers. Leon's a former CIO for hospital groups in Malaysia. The FDA and CDC first scientist is one of my senior colleagues. So we understand a lot of the challenges that are being faced by healthcare and research colleagues in this space, because in the past we have walked in your steps and walked in your shoes. But what we try and do in AWS and healthcare and life sciences, really, as I mentioned, we want to support the technology in the background so you can spend your time answering the science rather than trying to create the technology yourself. So from that aspect, what we look at is we make sure, and I think there was a question earlier, is make sure that we're trying to help support you in terms of the security, compliance, and the data privacy around the organizations and the data that you're using. It's about using the technology and the cloud platforms to accelerate innovation. So being able to test things very, very quickly. And if they don't work, being able to close them down and there is a reduced cost or minimal cost. Being able to take the data that potentially, we are traditionally seeing silos. Many organizations have very, very valuable data, but potentially they're not aware of what sister organizations may have. So how do we virtually aggregate that and allow the unlocking of that data to provide actionable insights across a patient journey or a research journey? And then really the panacea, the end goal is, making sure that the care we provide is no longer care that is similar to maybe 10,000 other patients like you, but is care to you as a singular person with all of the different things that are wrong with you that differentiate you from the next person with the disease. So how do we achieve this, and how are we working with IMERI-IDEALAB with the tools that we have to help you achieve this? And as I mentioned, we're here to try and help solve the technology aspect so you can focus on the science. What we often see our customer community is a spectrum. We have customers who have expert IT teams who learn cloud, who learn data science, research, and they will be what we would term builders. They're able to take services, they're able to take building blocks, they're able to take research tools, put them together, and then generate the programs and the applications they require. On the other end of the spectrum, which we often see in the hospital space, are the buyers. They may not have access to the same expert team of IT folk and researchers. So what they do is they work with partners, they work with systems providers, they work with consultancy firms who can indicate to them what do they need and help them run those systems. I think the journey that IMERI and BDC has taken in the last probably 18 months has very much been getting skilled up, using the cloud tools to become expert super builders, that those of you who are stakeholders in the hospitals who are trying to solve problems with the data that you have, maybe with rare diseases, you can leverage on IMERI-BDC as a conduit for them to help you with the technology so you can get insight from the data. Now, when I mention data, obviously there are a number of things we have to think about: data governance, data security, confidentiality. And for AWS, data security is our day zero, it's our job zero. We as a cloud company, we have to ensure that the platforms and the systems we have in place are as secure as the most secure customers we have around the world, which include ministries of defense and security agencies. So at AWS, what we have is a concept of shared responsibility. So AWS, we're responsible for security of the cloud. So when you are using cloud infrastructure, and in Indonesia, AWS, we actually have a region. So we have physical data centers in Indonesia that you can leverage that meet some of those governance concerns and regulations. So we're responsible for security of the cloud, where the data center, the resilience, resistance to natural disasters, the base software that you use, we make sure that those are up to date and they meet your needs. For customers, both Big Data Center IMERI and yourselves, what we identify is that actually things like customer data, what you do to that information, the applications that you run it on, we realize that that is your responsibility. The reason being that we don't want to see that information, we don't want to see the data, we don't want to be party of any intrusion. So a lot of the governance, a lot of the frameworks, a lot of the good practice around hygiene, data security, we would often look to our customers and the partners that they work with to make sure that they use the tools that AWS provides to ensure that that environment is secure. So no sharing of passwords, who's coming into my system, who's looking at what data, what are they using it for. So these are all things that you can manage, or you should manage and control. What we can do is give you the tools that allows you to kind of monitor and look at who's doing the kind of data access. But what are some of the services that are available to you that from a BDC perspective have put together, essentially the builders that are becoming super builders and expert builders. So what we have is a busy slide, but let me just break it down into the things that will be important to the audience here. Our core services and what AWS started at was really around data and compute, an environment on the cloud that allowed you to store information that you could access according to your identity and access management controls. And then on top of that data, running solutions, running programs, running applications that allow you to do things like host a website, that allow you to do things like sharing information between the right organizations, that allow you to do things like looking at genome sequences or x-rays. But beyond that core foundational service, we've also generated tools that allows you to start interrogating that data at an operational level, very operational analytics. What is my data telling me? Yesterday's data, this last year's data, what am I seeing from the data? What is the kind of insight and connections between that data? As we start moving into the big data space, which is obviously where IMERI and BDC come into their own, the volume of data that we see probably defies the ability of manual working to generate the insight. And that's where we then start seeing machine learning, artificial intelligence and machine learning, to do a lot of the searching, do a lot of the analytics, to do a lot of the deep diving into the information and how the information correlates with clinical syndromes, with the genome, with maybe the information that's coming in from remote monitoring tools like blood pressure machines, ICU machines, with an IoT, Internet of Things, medical device integration. So using those tools to streamline and focus where scientists and clinicians need to look at the anomalies in the data. Beyond that is using things like our user interface tools so that you're able to be alerted when some of those anomalies are detected, or that there is a unique link between some of the data that you're analyzing and maybe some of the hypotheses you're testing. And then, as I mentioned before, kind of the mainstay is the cybersecurity element. How do you protect your data? How do you protect access? How do you make sure that the applications you're running meet the needs of what you're trying to do in a safe, secure, and obviously agreed data-governed way? So let me take the audience through how we often see our customers working with AWS and the tools. And this may be a template for how you might wish to work with IMERI-BDC in the future, or maybe even make future asks of IMERI-BDC and how you could work together and leverage the tools that are available to them and the expertise that they have built within their core team. So a typical journey we see is maybe customers exploring what cloud might mean for them in their environment. And it might start with a hybrid cloud environment. So some of the things that they want to look at, they may host on cloud. The rest of the information they'll actually maintain in their own existing systems. But once they start exploring that environment, what you then start seeing is an ability to be able to store, protect, and optimize that information. Whether you're still protecting it in your silos or you're aggregating that information virtually, you're now getting a visibility of what information do I have access to in my healthcare environment. If I'm working with BDC, potentially what are some of the things that other colleagues are working on that are of interest to me? Leveraging the tools, as I mentioned before, analytics, AI, and ML, is to start interrogating that data and starting to get the insights that answer your hypothesis. And what we see in customer-facing organizations, so patient-facing organizations, is using some of those tools, some of those insights to essentially open a digital front door. How does a patient and how does a doctor, how do they engage when they're not physically in the same room? How do we use the technology so that they can continue the dialogue, continue the consultation? How do we use things like Internet of Things, medical devices, and the information that they collect, perhaps if I'm on a new treatment, to make sure my blood pressure, my respiratory rate, my heart rate is improving the way that the medication is meant to. So integrating digital therapeutics into that equation. And then finally, for the researchers and those that are looking at DNA analysis, epigenetics, proteomics, those elements of using the cloud to be able to crunch the precision medicine, your whole genome sequence of 150 gig. But if you've got a population of 1,000, 100,000, 2 million, 200 million people who you're trying to do that sort of analysis on, those numbers get very, very big, very, very quickly. So how do you use the cloud to drill down to what's important to you, both from a diagnostic perspective, maybe looking for disease, cancer types, but also from a therapeutic perspective, which is to understand how does what's available to me from a medication perspective or treatment perspective meet the needs of these new diseases coming through. What I'm going to drill down to is just 3 cases that really talk about how customers we work with that you may be aware of use cloud and how they've adopted cloud and use the services of organizations like IMERI-IDEALAB to answer questions that they have, whether it's questions in the longer term or questions that have been associated with COVID response. These will hopefully kind of jog memories in the audience. Let me just quickly skip that. So when I think about big data and what we do with that, I think about 2 aspects: a population health with a big P and a population health with a little p. And Leon may laugh at me because it's a very simplistic way of thinking, but population health with a big P is really around identifying cohorts. What is the population doing? How many people might I have with diabetes? How many people might I have with a certain type of cancer? What does that tell me about the health of the population? And how do I use that to potentially forecast how many more doctors and nurses do I need? Is the medication that's predicated for this particular condition, does it work in my region? Does it work for an Indonesian population? Or is the medication very predicated to a North American Anglo-Saxon genomic makeup? So population health is using the big P to look at the data, looking for size and scale. I'll just quickly run through. The NHS in the UK, so the National Health Services, they started a journey on cloud many years ago with us. Their initial foray into cloud was very much around hosting a what they call the European health insurance document, which basically means before people from the UK with their travel into the European Union, Germany, France, if they fell ill, they could actually benefit from healthcare on the public sector in those regions without money needed to change hands, because the NHS was able to host a European, essentially, health insurance license that allowed UK people to travel overseas. So they started with that, which is a very kind of administrative, operational application. But it was a start of their journey onto cloud and moving on to cloud native. So solutions and applications and insight that they want to do, they should be looking at cloud first. What they then pivoted very quickly to in the last couple of years was using that cloud platform, the information they were collecting about COVID patients that were turning up to hospitals, to actually help them identify, explore, and refine how they were responding to COVID numbers around the United Kingdom. So using the information they were collecting, anonymized, to identify heat spots, where in this particular region am I seeing more COVID patients? What sort of patients are they? Are they more male? Are they more female? Are they older? Are they younger? Do they have more than one disease? Can you tell me a little bit about how COVID is expressing itself in my population? And what that allowed the NHS to do is then to deploy its staff, its resources to those areas that were harder hit, and then identify what that meant in terms of, what am I seeing here? Is there a particular medication? Is there a particular treatment that I can understand to treat COVID better? Since then, last year, what the NHS has started doing is understanding what other solutions and what other platforms they can use on cloud that allows them to scale very, very quickly beyond a small population to the nation of services that are pertinent and important to patients getting access to see the clinicians, the doctors and the nurses. So from that respect, there are 2. They have an E-Referral Service, which is how patients, when they go see their family doctor, They get referred into the hospital and the clinician of their choice that provides the most appropriate services. So it's almost like I can choose within reason the specialist I want to see in the hospital that I prefer. The second aspect of what they were doing with cloud is really opening up their NHS 111 directory of services. Now, what that does is it enables citizens, but also members of staff, to understand in their region, but wider, what services are available for healthcare treatment, which clinics are open, where are the specialists, what's the capacity that we're seeing here, but also to answer some health questions. So almost like a citizen and population facing decision support. With these particular problems you have, maybe you should go and see your GP, or maybe you need to go to emergency department and be seen. So that's an example there. From a New York City perspective, New York City was using the cloud to help them aggregate all of the data that they had across their 5 different states, who were all using very different healthcare system, IT systems, and the data was being collected in different formats. So the end result here is where they were identifying those at risk who needed reach out in case they would get exposed to COVID. But the precursor to this use case here is the hard work that the New York City Department of Health did, working with AWS and a number of other partners to aggregate all of that different data into a data lake, to do the mapping, so like for like data, age, date of birth, conditions, medications were mapped appropriately, which then allowed New York City in March of 2020 to then start getting a real-time operational overview of what was happening in New York, which before in their 5 different disparate statewide systems, they couldn't do that. So they weren't able to mount a response in a coordinated manner. What New York City was also able to do with the information that was collected beyond just where are the beds and how many beds are being used up, was then to start looking at the, and this is a decision they made, start looking at the identifiable patient information. What patients are coming into my hospital? They look like they're over 50 years old. It looks like they're predominantly male. It looks like they're predominantly ethnic minorities. It looks like they have 2 or more conditions, comorbidities. Those are the ones that come into my hospital, but more importantly, those are the ones that are ending up in ICU on ventilators. So New York City was then able to, as well as a real-time view of, or near real-time view of where the beds were, where should I be sending my ambulances, but also to start understanding who is being hit by COVID, and therefore, with this particular use case, leverage social services to make sure that they were reaching out to these people in advance before they got sick and giving them things like COVID packs, hand sanitizer, gloves, masks, as well as ensuring that they weren't exposing themselves by going out and doing shopping. So these are examples of big P, population health, where we're doing things to see what can I do to serve the wider population. Population health with a little p is very much around for the patient, for you or me when I go and see the clinician in the clinic, or using telemedicine, teleconferencing. What options are available to the clinician when they're hearing the story I'm telling them and they're advising me. So I think in this space, we often think about a personalized medicine potentially like a smart hospital. I collect information, I interrogate the information, I use analytics and AI/ML on the vital monitoring, which then provides me an ability to say what the treatment plan should be. And as I'm using ML and AI and ML, I find out more and more about what's happening with the patient. And then it becomes a virtuous cycle where over time, the services you provide are at a citizen level, using many of the Amazon tools, which really ultimately are about integrating with a data lake that you can access, managing that data, building notebooks and algorithms that start helping you identify if Julian is a diabetic, is he like a diabetic with all of these other patients, or is he a unique diabetic because he has something that's slightly different that causes him to kind of change the treatment I should be giving him. So instead of metformin, maybe I should be looking at diet control and exercise. So these are some of the things that I think some of our colleagues around the world think about when they think about smart hospital. And the technologies can support them, which collects all of this information and all aggregates into big data. For those of you that aren't aware, Amazon Halo is a hardware device. It's actually I don't have one, Leon has one, but essentially it's a wrist-worn device that collects your usual things like steps, heart rate, and so on. But when you integrate that information into an application in the background that also uses a mobile phone's camera for computer vision, you can start then thinking about, how do I use this to maybe monitor rehabilitation? You know, for a patient that needs to do physiotherapy for upper or lower limb injuries, how do I use this to make sure that they're going the right way? Neurologics is one of the startups that we're aware of that uses the camera and computer vision to do non-touch vital signs monitoring, heart rate, respiratory, based on the computer image that they take from a facial picture, a facial video that they take. Chronic Care is a Singapore-based startup that uses an infrared camera attached to a typical mobile phone that allows them to look at chronic wounds and understand the depth of the wound, the extent of the wound, and over time using the AI and ML they've built to teach nurses of, you know, what to look for, maybe the treatment options, and a way of kind of essentially bringing e-learning to maybe a cohort of staff that don't see that many wounds or are unfamiliar with wounds, leveraging the expertise of chronic wound nurses and chronic wound teams that see this very, very much. So it's around e-learning and promoting that using these particular tools, but also monitoring. When you collect all of this information from patients, from each of us, bridging that gap between the patient and the provider potentially sometimes may require a solution. There's a New Zealand company that we work with called the clinician ZDoc. They take a lot of this information, they put an interface into the patient's hands in terms of a mobile application and the provider, so the doctor, so that treatment, following of treatment, compliance, how well a patient is doing, how do I feel today? They're able to monitor that and you answer questions so that over time you build a much better picture of whether a patient's improving or not improving over time based on different treatment modalities. But they analyze and they use the population big P data to then start refining and personalizing to little p data, which is me. You know, I'm no longer part of that 10,000 cohort. They've now identified that perhaps I'm one of 100 cohort because I have certain things around me that are unique and therefore my treatment needs to be modified. My last example before I hand over to Leon to talk about some of the kind of cutting edge what we're seeing in AI, ML and big data is CSIRO. So CSIRO is the government research agency for Australia. What they've done, so Professor Denise Bauer there uses AWS in her research on genomic disease. And September the year before, they are what we would call expert builders on the scale of using AWS. So they built their own AI engine to analyze genomic data, which they make available actually to the world on AWS Marketplace. But the particular experiment that they did was really around analyzing 1 trillion points of genomic data through their AI engine to look for specific disease traits. Now, that may not sound extraordinary other than the size of the data. But what they did, because they were able to use AI and ML to do a lot of the heavy lifting and crunching that a physical human being could not do, what they found was basically it took them about 15 hours to process these 100,000 kind of individual data sets with 10 million variants. It took them 15 hours to do that. If they'd used traditional technology, it would have taken them 100,000 years to process the same. And more importantly, and what she laughs at is the fact that it probably cost her less than a cup of coffee for a couple of weeks to do that. Whereas in the past, it would cost you, you know, when the original genome was sequenced, it was billions of dollars. Now we're talking coffee change money to potentially do some of these things. So that's what cloud can enable you to do. And as I mentioned, you know, congratulations to the IMERI Big Data Center team for developing the capabilities that they have. But these are some of the things that, you know, if you're not already doing it with them, maybe you can nudge them, ask them, I'm really interested in exploring this size and scale of innovation that we can do. But let me hand over to Leon, and Leon, I'll drive the slides for you.
Thank you, Julian. Let's talk about some common architectures and designs that we see customers applying. Let's start with building trusted research environments. And I'm running through a lot of concepts here. I think we can click one more time, Julian. Yeah, I'm running through quite a lot of different concepts here, but I'm hoping that some of this would sort of jog your interest, and then we can have further discussions with IMERI. One of it would be building these trusted research environments where you're solving the problem of how do you control privacy and all these other aspects of patient data and real world clinical data that you want to make available to researchers. And what you are doing is creating a very secure environment so that researchers can visit that data without moving that data around, right? So that's the heart of this idea. And with it comes, the data classifications and controls, your ability to build very granular access down to tables and rows and even files for different researchers and different roles that they have. We also talk on the top here, you can see that, about passports and integrating with communities like GA4GH and bringing your own identity. We also talk about... Sorry? Okay, I thought that was a question. Yeah, so, and then building it in a way, structuring it in common data models like Odyssey's OMOP that's very popular with researchers. And then on the right, you can see that all that data can be interrogated and made use of by the different analytical services on AWS. Whether it's federated queries across different silos or Spark clusters on EMR or data warehousing, etc. Right? Next. And how would researchers interact with the data? One of the ways that we see happen a lot is these self-service research environments. We've opened and shared openly the source code for this and the link is here, something called Service Workbench that can put these pieces together to automate the building up of the tools and the environments that researchers would need. And creating a catalog and a library of the different data sets available in that environment, and also putting in workflows for permissions against budgets and things like that. But the idea here is then the researcher would be able to help themselves get the permissions they need, have access to those data and the tools that they need to run in that environment, right? And again, all of this can be built in a very secure manner so that researchers are able to visit these environments, make use of the tools in them and not remove any data. The data stays secure and in that construct of privacy and security. Next. One of the things that you saw on my diagram earlier is this idea of beacons. These are really useful. It's an open source protocol for making anonymized genomic data discoverable. And so research communities that connect with each other's beacons. And in this example on the left is a service by CSIRO that runs on our serverless infrastructure, meaning that to get it up, it's just a matter of code and not even having to manage infrastructure. Then you can set up these beacons where you're able to then advertise that, I have these mutations of interest and be able to interrogate each other's beacons. And this helps advance the use of discoverability of this genomic information different silos and different research organizations have on a community level. Next. And so one of the big reference examples we have for population genomics and the idea of taking all those libraries of genomics information and making them available to researchers to drive more insight and discovery is Genomics England. Next. Let's look in a bit more at genomics and what does that look like, right? So we know that when you run these pipelines, whether you're looking for single markers or polygenetic diseases and all these other things that are possible today with different open source tools that you could run on AWS, you need access to high performance computing infrastructure. And what we do is make that easy to create these pipelines on AWS to do this analysis. And at the end of that analysis, if you can press the button one more time. At the end of that analysis, as you're doing more translational work, you may need access to phenotype data and clinical data from other sources. And so a lot of times these privacy preserving constructs are built. It could be data from the electronic medical records or medical devices, can be patient reported, integrated with FHIR connectors or normalized, with the Odyssey or MOP, as we were saying just now. Pathology data can be fed in, and all of this ends up in a place where you do multimodal analysis, combining, the markers of interest from a VCF to the phenotype data that you have normalized to one of these data models, and then, essentially biomarker hunting and looking for bits of information that you do translational medicine with, right? So a lot of this is happening on AWS. Next. And, examples of multimodal analysis are abundant. Next. If we zero in a bit about how you would, deal with data that comes from all these phenotype sources, plus, tagging and indexing genomics data so that it can all become features that you do machine learning on. Julian gave that example of variant spark earlier. In this example here is example from Databricks with Glow. But all these are the different approaches that different customers use. And then sometimes, on the right, normalizing that, tagging it to a data model like OMOP. And then also building these connectors and ingesting a lot of data that may start with FHIR and normalizing that to the model that you want. And then all of that being sitting on a platform that we call a lakehouse architecture, where you can interrogate and run the different analysis that you need on that, right? And then in this example, one of our partners, Linear, specializes in connecting to those different data sources and normalizing it into something that you can use. Next. And what we mean by lakehouse architecture essentially is this idea of a data lake in the past, where you are able to ingest all these different sources of data and put it in an object store. But now you're able to then interrogate it with structure as if you were working with a data warehouse, right? So it's a bit of the best of both worlds, where you're able to collect these disparate sources of data and now aggregate some kind of model and order on top of it to be able to run more complex interrogation of it, right? And another thing about running lakehouse architectures on AWS is the fact that we have a lot of federated query service, like in this example, using Athena to be able to do SQL query to different sources of data. And that alone gives you a lot of liquidity in terms of being able to unlock insights. In the past, you have to try and integrate these different systems. Now you can actually put that data on AWS and interrogate it across these multiple silos. Next. So examples of population health as well. Here we're talking about Rush and their use of Health Lake, which essentially is our service of making FHIR data into a format that you can interrogate and explore. Next. And another one of the things that are happening now is, as Julian talked about, telemedicine is creating connectors now, in a world where we can make a lot of interoperability based on an API call using protocols like FHIR. You can now start to connect the dots between a telemedicine service provider and an existing healthcare system. And telemedicine can actually become a part of normal healthcare. It can be the port of first call for a lot of citizens in a country, and become the starting point of their primary care, and then be part of integrated care, right? So the way we talk about shopping now being hybrid between online and in-person, a lot of care is also moving that way. Next. And so for data interoperability, we also have a big ecosystem of partners and customers. Next. And one point to zero in here is the fact that, we know that medical devices generate a lot of data, and we know that making sense of it, we have a lot of IoT services, which I'll go into the next slide after this, but we have different IoT services to help you aggregate and manage that data at scale. But an important factor then is also deciding where it goes into the record, and there are places in FHIR resources to be able to store that. Next. We also at AWS provide a lot of services to deal with IoT and IOMT data from edge devices that can sit on site and be able to deal with even offline access and aggregate that data and stream it to the cloud, or mobile application services that you could then listen to a device that's tethered off to a mobile device, a handphone, smartphone, and aggregate that data in, right? And we have different tools for dealing with data that streams, being able to unlock insights from the live stream that's coming through and trigger events that are able then to trigger different actions and a whole sequence of software-driven events after that. Next. Also from the example given earlier is machine learning for computer-aided detection. This is a big thing. Computer vision is quite mature now on the cloud. There are a lot of different stacks and different approaches that you can use for this, but essentially, and the fact that there are a lot of models that are already built, transfer learning is possible, and there's quite a lot that can be done. Next. And how does the data get there? We also have mechanisms for getting data from on-premise medical imaging systems to be ingested and end up in your cloud environment, so that you could do AI ML, with Sagemaker. We'll talk a bit about Sagemaker after this, and other platforms that we have like that. The other thing that we see a lot of as well is, instead of moving data up and down, when you get it into the cloud, you could also use a lot of these reporting environments and tools through services like AppStream that can AppStream and workspaces that can actually stream 4K environments, and the users can actually interact with those tools in that environment, and they're actually streaming access to those applications that are running off the cloud instead of moving data up and down. Next. Right, and we have big two of the most exciting references I can think of for medical imaging is University of San Diego Health story of how they were able to model COVID from chest x-rays, and that story is online. And then also read about UMC that has this ongoing challenge where different communities actually come together with them and go after different CAD challenges with AI/ML for medical imaging. Next. So when we say machine learning, next please. And next, when we say machine learning, we're talking about that subset of AI, right? And if we can move to the next slide. On AWS, we provide a big stack and environment for this, all the way from the bottom of running your own stacks and environments to using a nice managed service and tool that we have called Sagemaker that has everything from your data preparation and training to the ability to run ML ops and be able to reproduce your environments and automate it, to the top where we have these ready services, for example, computer vision with recognition, or Amazon Health Lake is, allows you to search through FHIR data resources and, comprehend this natural language processing to SNOMED and ICD-10 from unstructured text, right? So there's these different services that are available just through an API call that you could build into your workflow and your tool set. Next. And Sagemaker is really a great way to start with machine learning. It's a very big and vibrant community that are doing a lot, all the different stacks and tools and algorithms. And it really does take the users through the different steps, from labeling their data to training models, to dealing with their tuning and their training and, dealing with parameters, and finally to being able to deploy it in production and continue to improve it. But the most exciting part is the fact that the whole process and everything that you do can be automated for MLOps with processes that you're used to when you're building software like CI/CD. Next. Right, and so we've got many ways you can work with IMERI to get started with machine learning. From, we have structured courseware to an organization called ML Solution Labs that can help you get started with different projects, to different services that increasingly we are creating more and more services that are more user-friendly to get started. And to newer services like Sagemaker Canvas, where it's a lot easier to explore visually what you're doing. Lastly, I'd like to talk about an example, the next slide, how MedHost got started with Sagemaker and machine learning, and were able then, to very quickly get to a place where they were able to score cardiac risk from the different data silos that they had. Yep, I think we're slightly over time. I'll hand it back over to.
So thanks, Leon. Thank you very much to the audience today for giving Leon and I time to talk to you about AWS Cloud, obviously how we're supporting IMERI Big Data Center, and some of the things that our customers elsewhere around the world are using these tools that IMERI and BDC are trained up in and expert in to be able to solve healthcare life sciences questions. So at that point, I'll stop here, and if there are any questions, we're more than happy to try and answer those during this slot. So thank you again. Terima kasih.
All right. Thank you to Dr. Julian and Leon for a very nice presentation. I think it's a very mind-blowing presentation. So I'm hoping to get questions from the audience. I think I know Leon already answered the question, but I will also give chance to Dr. Julian to answer one of the questions from the audience from Dr. Muhammad Habibur Rahman. So let me read the question from the chat box. So good morning, speakers. Have you heard about dataset repository websites from, for example, Dryad and Zenodo? I'm wondering if we have posted or published our research datasets at those repository data platforms. May we still upload, save, and publish the same dataset of our research in Big Data Center IMERI? Will it make us get plagiarism or ethical issues? And thus, what is your suggestion to avoid that issue? Leon already gave a comment, so I'm going to give Dr. Julian a chance to actually answer the question.
Sure. To the first part of the question, no, I'm not aware of those data sites. Obviously, it may, should be something that you can share with me afterwards. What we do often work with in the international space is essentially a open source community. So opendata.gov is an example of AWS, where we work with many international organizations to publish data sets, including things like the whole genome set, cancer data sets, and the rest. I think for specific cases, if there is data that you are wishing to publish, depending on the use case, and obviously ethical data governance, security things, would be things that you would need to agree with the stakeholders of the data, and then understand whether that is data that should be, according to the way that IMERI-BDC categorize it, should it be in the public domain, private domain, or restricted domain based on the usage. So I think the second part of the question of can we publish this on IMERI-BDC, I think it really depends on what the intent of the data will be, who you believe should be accessing it, and what they will use it for. And that will inform the level by which you believe this data to be published. But We have seen other people around the world publishing anonymized data for the use of sharing amongst the research community to essentially speed up collaboration.
Thank you very much, Dr. Julian. I think that also echoes to one of the slides from Prasandhya's presentations. So Prasandhya already presented what's the regulations of the BDC IMERI regarding the data that you can upload and who can access that data. So actually, Dr. Muhammad, is a very good question. So I think you can also refer back to the answer from Dr. Julian and also presentation from Prasandhya. All right, so any other question from the audience? If not, then let me start with, I think, because of the COVID-19 pandemic, it's actually placed a very extraordinary demands on the healthcare industry. And I also, not only me, but I think, so despite all the difficult circumstances, the industry response demonstrated quite a good resilience and ability to actually bring what is the necessary innovations to modern healthcare system, and that includes Indonesia as well. So, so to today's adoptions of the new technologies with the industry, actually expanding volume from a digital data from the very classical data before that have actually pushed the healthcare organizations in Indonesia to seek new solutions in IT. Especially for IT infrastructures, and that includes the data center. So my first question will be, why, well, according to your expertise, Dr. Julian and Leon, so why data centers play a pivotal role in enabling healthcare interoperability? I know, Dr. Julian, you already mentioned on your presentation about how NHS actually use the AWS services. And this is actually, I think, correlates with the question about the enabling healthcare interoperability through data centers, please.
So maybe if I answer the first bit and Leon, by all means step in. I think one of the things about using cloud is, for somebody like AWS is, yes, we obviously have physical data centers, we call them regions, and we have one in Indonesia, but we also have them in Australia and Singapore and India and Korea and Japan and the US and all around Europe. And I think one of the things that we see is that once you take the data governance and the regulations aside, the thing about hosting data on cloud is, with the right frameworks in place, the researchers and the clinicians that need access to that data have the right level of authorization. They just need an internet connection to be able to access it. They don't need to go to a secure place. They don't need to go and download it. You don't need to download gigs and gigs and gigs of data onto a laptop. You can essentially look at that information and run your analytics and AI ML on that information in the cloud environment. So you're no longer restricted by how powerful your laptop is. In a way, you're almost restricted by how good is your connection to the internet. But what it does do, certainly within the research community and clinical community, which we've seen during COVID, is it allows people between different geographies with the right ethical agreements to start understanding, for something like a global pandemic, does COVID react differently in a Chinese patient to an Italian patient, to an Australian patient, to a British patient? And they are, collaborating on those insights. So for me, the reason that a data center, in inverted commas, a cloud hosted information, so move it away from a physical representation, but the data is wherever you need it to be. Once you start removing that thinking of it's in one place, and you get the ability of people to share, you then get collaboration, which speeds up research. Leon, do you want to jump in and maybe expand on that?
I think to add to that as well, when you work with global cloud providers, you have then access to networking and security and this kind of technology that operates at a scale even larger than the healthcare industry is normally used to investing in. And I think that's one of the biggest benefit is tagging on to this infrastructure that's used for broadcasts, for many other industries that spend a lot more than healthcare, and making use of that for healthcare to be able to connect different researchers, different sources of data. This ability to network at scale and keep it secure is something that we really appreciate and benefit in the healthcare industry, that we can write off this, share with these other industries and write off this infrastructure. Yeah,
thank you very much, Julian and Leon. If I can continue your statement. So by having the data centers, then the problem, the current problem in Indonesia, let's say one patient from North Sulawesi, and then they want to travel to Jakarta to get more medical services here, right? So I think by having this data center, it's actually enabled information between clinicians. Is that correct? Will it be like that regarding the interoperability? Yeah.
Leon, do you want to start? Or do you want me to have the first crack?
Yeah, I think it's a combination, right? So the data center is one aspect, but then the fact that when you have cloud and when you have interoperability services, and when you put in place the ability to share, communication protocols, or you use natural language processing to normalize different sources to make shared insight out of it, right? These different factors kind of build up. And I think what we're doing around the world is facilitating that on a technology level with the right partners like IMERI.
Yeah. And just to follow up, I think to that scenario you're talking about, Dr. Eric, in Korea, what we saw during the pandemic was hospitals, rural hospitals that had suspected COVID patients that needed a second opinion from one of the central hospitals. Yeah. They could use cloud services to essentially share, without sending a 20 gigabyte file over an internet connection, essentially share the view of an image. That meant that the tertiary hospital could quickly look at the image, CT scan or an X-ray, and go, yes, it completely meets either typical, atypical COVID, you should transfer the patient. But that wasn't based on an actual IT system they had in place between them. But because they had the right agreements and data agreements, they were able to very quickly share that image. Similarly, organizations like Genome Institute of Singapore, here in Singapore, who do a lot of the research, food safety type stuff, because of the way that they've hosted a lot of their data between researchers, because of the way that they are now managing their environments and how they sequence genomic data on AWS, they're able to essentially establish satellite offices where you can have people working from overseas on the same data, and there is no performance cap, because essentially they're accessing a virtual data center from wherever they are, but they're seeing the same information. And I think in the future, certainly for Indonesia, when the authorities in the space where obviously things like data agreement, patient sharing, and provider, hospital agreements of who you can see, cloud is certainly one way by which you can speed up the ability of sharing that patient's information and expedite diagnosis, management, and treatment, for sure.
Correct. Thank you very much, Dr. Julian. So I think to conclude the first question, so by having those very ideal situation, I mean, the data centers actually will be making a patient health records probably more accessible across all providers, will also significantly reduce the cost, improve the treatment efficiency and treatment outcomes, and definitely will minimize the administrative work. Yeah. So I'm going to give another chance to the audience. You can also raise your hand if you want to ask a question to Leon or Julian. All right. So I'm going to continue with my second question. I actually have thousands of questions for you both. So my second question is about the collocation service. So what do you think about this? I mean, is it safe? that probably the biggest question for all the healthcare providers. Is it safe to use a co-location service that can act as an alternative? Or I want to hear your comment about this.
Leon, do you want to have first crack on this one? This is more in your territory.
It's very hard question to answer because, you know, if you think of the cloud as the vault, centralized vault, or, you know, a network of vaults, and then a co-location service could be essentially a safe that you put somewhere else, right? And, you know, the safe could come from us. We have something called Outpost, but the point is, you know, how safe is that safe, you know, in terms of physical security and things like that. That's a variable that you know, that's an unknown, right? Yeah. But having said that, I think, you know, as we build a network of partners, because, you know, as for example, with IMERI, we may be building a hybrid cloud scenario, right? And so then a lot of those agreements and the structure of security and how we manage that could be something that is worked out with IMERI on that. But again, it's an unknown variable in terms of when you take from a network of vaults to, you know, actually having a safe that you put somewhere. There's a few other variables introduced, no matter how good the safe is.
Yeah, I think maybe just to kind of describe the spectrum, I think there are plenty of cloud customers out there who, for whatever reason, have to have various scenarios, whether it's colo, whether it's hybrid, whether it's, you know, data must remain within the kind of premises. Those are customers we have worked with in the past, and we're working with them to understand what their needs are and the security arrangements, you know, worked out a viable solution that meets their needs. So to what Leon was talking about, Outpost is where potentially you bring AWS technology, so physical AWS technology into your own environment, into your own data center, and you insert it in the rack in your data center. Now, what that's meant to do is be able to pull the speed and the size and the scalability of AWS services within your own organization. Usually we may see that in a region where there isn't a physical dedicated AWS region like we've got in Indonesia, but we certainly have government customers elsewhere where they are comfortable with AWS and AWS meets their needs. But for them, it's about, I'd rather have the speed of AWS in my country, and they look at Outpost. We've also got other customers who may be using AWS for the applications in AWS, but have the data within their own organization's kind of technology. The rate limiting step for them in that particular instance is how quickly can that data be interrogated by the AWS services. But again, difficult question to answer, but what we would normally do from an AWS perspective is understand the customer's needs, what requirements they're working to, what some of the security things they have to adhere to, and then try and work with them to architect a solution that works for them, meets the needs, and that they are comfortable with.
All right, excellent. Thank you very much, Dr. Julian and Leon. I think we have one question here from Mrs. Sukma Purbo. So the question is, where are the servers located? I think Dr. Julian already mentioned that, but yeah, please, Dr. Julian, you can explore more about this. Is there any in Indonesia?
Yes.
So would be used regarding the data security?
Yeah. So December the 13th last year, so 2021, AWS actually launched our Jakarta region in Indonesia. So there's what we would call a region as a physical entity, a number of physical entities based in Indonesia that hosts Amazon AWS technology to deliver cloud to the citizens and population of Indonesia. We don't normally disclose, or in fact, we don't disclose where those physical locations are. Suffice to say that working with the Indonesian government and the regulators, those particular regions meet the security requirements of Indonesia for public sector uses, which is the same as in each other country we work in. We endeavor to meet the requirements, security requirements and other requirements of those countries, each country potentially being different. But the technology we bring to each of those regions is the highest level of security and capability and redundancy that we would give to any of our customers, including the most sensitive customers that we have worldwide.
Yep. I'll just add to that if you
Yes,
work
please.
with if you work with IMERI or the local team in Indonesia, you can probably get the details in terms of certification and compliance of that Indonesia region.
Okay. All right. So I think the question's already answered. So thank you very much, Dr. Julian and Leon. I think I only have one more question, but before that, I will give, if we have one question from the audience, please. You can raise your hand or open your mic. All right. So Dr. Julian and Leon, this is, I promise this will be my last question. So the use of artificial intelligence in healthcare, especially in Indonesia, is I think for now it's not quite implemented yet. There's so many skeptical questions that probably starts about 1 or 2 years ago about how AI that will replace doctors or healthcare providers. This is a very general question. So if I can give you like probably 1 or 2 minutes on how to best convince the healthcare professionals in order to equip AI to help patients better, to help the healthcare services management, to help the clinical decision making, to help the patient data diagnostic. And also, it's very interesting to learn from one of your slides about the predictive medicine in Indonesia. Please, probably Leon, you want to start first?
Sure. And I'll just say, as the software guy and Julian's the clinician.
This is a great combo.
Yeah, but as the software guy here, I will say that nobody in healthcare actually thinks that AI will ever replace doctors. Usually, I think this comment and concern is outside healthcare.
Yeah.
That don't understand the complexity of it. So I don't think it's ever getting there. If anything, all we are getting at with AI is better decision support for clinicians, who ultimately make the judgment call based on very complex parameters, including trade-offs that the patient is agreeing to, right? So not all decisions are pure logic. A lot of it is also what patients want. Having said that, I think the way to kind of progress with this is, number one, create these research environments that can have data, because AI needs a lot of data. And so we need to create these constructs of privacy-preserving places where we can get access to that data for training. The second one is then creating sandboxes where actual clinicians, researchers are able to get used to it and experiment with those tools. And then the third one is probably the national kind of governance in terms of how do we deal with AI, how do we deal with bias, how do we deal with monitoring and supervising AI on a national level, and what are the policies and trade-offs we're willing to accept. Sorry, Julian.
Yeah, I put, like Leon says, I come probably more from a clinical background. And I think to that query of AI replacing clinicians, that's not the intent. This would never be my intent. AI, if you're using AI and ML, it's there to augment and support the clinicians so they can dedicate more of their time to actually looking after patients and doing the research. So when we think of AI and ML, we should probably look at it as a spectrum. AI and ML can do something as mundane as maybe checking documents that they're completed. Are all the fields in this document completed because I've sent for a claim? Or maybe I'm using it for fraud detection in a claim. And it can go all the way to the far right-hand side of, I'm using it for pathology, slide detection, or CT scan of lungs to look for anomalies. But within that edge use case there, it's around helping the radiologist prioritize and triage. If I have 100 scans to look at, which is the most urgent I should be spending my time on? Not necessarily using the AI to make the decision for me, but helping me pull all the information and go, these are the ones that seem to be, based on the training I've given it, seem to be ones you should be looking at now. And then you can go through the other 99. And I think going forward, the use of AI and ML by many of the practitioners, whether they're startups, they're providers, they're tech companies like us, should always be governed by some of the rules around AI, fair, transparent, and all the rest. And obviously the experts who understand the science should always be the ones that are helping to drive the development of the AI. Folk like us, we're there to help the technology aspect to make the training and the development and the deployment easier.
Very nice. Thank you very much, Dr. Julian and Leon. I think I will conclude this session. But first of all, thank you again to Dr. Julian Sham and Mr. Leon Jackson from AWS. A very nice presentation, a very fruitful discussion. So I'm hoping to actually from this discussion will bring more information to our future users for the BDC, IMERI, and also in collaborations with AWS. I'm hoping to bring more research that can actually help the patients and family, and also that will be great. Probably in the very near future, we can cut off all the unnecessary healthcare expenditure, but by using this data that can actually bring more information to the clinician how to best manage their patient using data for prediction medicines and so on and so forth. So again, thank you to you both again. Thank you to Big Data Center IMERI and AWS. I'm going to give it back to our MC.
Thank you. Terima kasih.
Terima kasih. Thank you.
Terima kasih.
Thank you.
Thank you so much for Mr. Leon and Dr. Julian for the informative and interesting presentation. And thank you for Dr. Eric. It's many and great question. Baiklah, untuk para peserta diingatkan kembali untuk mengisi absen dan link survei untuk keperluan pembuatan sertifikat. For audience, we inform you to fulfill the link of attendance and survey to make your certificate. Thank you. Hadirin sekalian, akhirnya kita sampai pada akhir webinar ini. Sebelum saya menutup webinar, saya ingin mengucapkan terima kasih banyak atas presentasi yang informatif dan sangat menarik, serta partisipasi audiens yang sangat aktif. Semoga webinar ini bermanfaat bagi kita semua. Amin. Please give applause for the speaker, moderator, and for you all. Dan saya, Indah Ramasari, sebagai pembawa acara hari ini, mohon maaf atas kesalahan yang kami lakukan. Terima kasih. Wassalamualaikum warahmatullahi wabarakatuh. Dan untuk informasi, sertifikat akan dikirim ke email Anda 2 minggu setelah webinar. For your information, the certificate will be sent to your email 2 weeks after the webinar.
Thank you very much. Prof. Egar, Dr. Rina, Dr. Eric,
Thank you,
Mr. Leon, Mr. Julian.
Thank you so much. Terima kasih.
Terima kasih banyak.
Terima kasih semuanya telah
Terima kasih
hadir.
Mbak Indah.
Nanti fotokopi kan, cukup fotokopi atau bisa.
Terima kasih.
Terima kasih sudah hadir.
Ya, kan udah belok deh. Ini kenapa mouse aja bisa sih?